Hi, Miss Marion here. So we're going to go ahead and we're doing a Unit 5, Lesson 10. And go back to page 191. We're going to read the I can statement. I can create a graph of nonlinear functions with pieces of linear functions. And so we're going to kind of talk about what that actually means and what it'll looks like today. Give yourself a sentence and how you feel right now. And then also give you your numbers. So number 1, I don't remember. 2, I kind of remember it. 3, I do remember it. And then 4, I can teach it to my friend. All right, go ahead and turn to page 85, and we have this picture here, and you're going to write down one thing that you notice and one thing that you wonder. So pause, and then go ahead and come back to me. All right, some things that you can notice is that not many of the points are on the blue line. The temperature gets warmer, and then it gets cooler after time. About 5:45 is the warmest, and it's about 59 degrees. And the second blue line connects the highest point and the point farthest to the right together. Some things that you can wonder, what location is this data represent? Why is it warmer at 6 a.m. than it is at noon? Why aren't the points connected? Why is the second line lower than almost all the points? Why doesn't the blue line go through all the points? Anything kind of in that sort as far as things you notice and things you wonder, getting our brain thinking about these kind of graphs. So here are some different graphs of what we're going to be talking about today. We're going to be talking about piecewise linear functions. And what that means is you can kind of notice, look at the graphs and see how they kind of curve and then they kind of come up and then come down. But what we're doing is we're drawing a linear line, so a straight line on this information to kind of show the trend. What is happening with this information? What is happening with the data? And then we're going to understand and kind of figure out the story that goes along with these graphs itself. Again, these are called piecewise linear functions, meaning see how there's different pieces with it, right? So we could draw a line like this, where it just goes straight and up and then straight down, or we can do tiny bits and pieces of a line that shows more of the information and what is actually going on. So let's go ahead and turn to page 86. On page 86, we're going to approximate the percentage recycled each year with a piecewise linear function by drawing 3 to 5 line segments to approximate the graph. So go ahead and draw on your graph the different lines as far as what we can actually go ahead and do, and then I'll show you what I went ahead and did. So go ahead and pause, draw your lines, and then come back to me. All right, so kind of what I did is I wanted to connect this information together. So I am going to draw a line, let's do red, between this point and this point. So see how this line kind of goes in the middle of everything. And then I'm going to go ahead and draw a line like this because it kind of goes down a little bit. And then we know that it's going to go kind of up. And then eventually it's going to come back down. And so what I'm trying to do is just kind of put all that pieces of information together. And so these are my pieces of different lines going on the graph. Then it says, find the slope for each piece and what does the slope tell you? So go ahead and figure out the slope. So remember, it's the change of y, right? Our slope is the change of y over change of x. So how does the y's change and how do the x's change? And also remember, it's always x comma y. So go ahead and pause and answer that question and then come back to me. So what we're going to go ahead and do is we're going to go ahead and find the slope of the first section. So we have this point and this point. The bottom point is 1991, comma, about 16. And the top one is 1996 and about 22. So we can go ahead and we can find the slope of this first part. So remember, we're going to do the difference between the y's. So we're going to say 22 minus 16 over 1996 minus 1991. Okay, let's grab our calculators. And let's go ahead and figure that out. So what is 22 minus 16? Well, that's 6. 1996 minus 1991, that is 5. So our slope is 6 over 5. Let's go ahead and let's label that. So the y stuff, if we go back and look at our graph, Our y stuff is percentage. And our x stuff down on the bottom are years. So I'm going to label that. So what is it saying? For every 5 years, it goes up 6%. Now let's go ahead and let's find the slope of a second part. So we have these two, right? So the first point is 1996, and then the second point is 1999, and about 21.5 or 22, okay? So we're going to say 21.5 minus, because we're doing the change of the y's, 22 over 1999 minus 1991. So we're in 21.5 minus 22. And we're going to get a negative 0.5, and that makes sense because our line is going down the hill. We're going to go 1999 minus 1991. What is that? That is 8. So let's do negative 0.5 divided by 8 in our calculator, or we can do it as negative 1/2 being divided by 8, and that is negative 1 over 16. So let's go ahead and let's label that. So we have 1% over 16 years. So it's going down 1% for every 16 years. Let's do our next piece. So let's go ahead and do this top point here. That top point is about 2011 and probably about 26. So we're going to say 26 minus 21.5, 2011 minus 1999. So 26 minus 21.5 is 4.5. 2011 minus 1999, 12. Let's do 4.5 divided by 12. And let's do 4.5, we know is 4 and 1/2. We're going to say that divided by 12. Put it in your calculator, simplify it down, and we're going to get, I'm going to put it kind of down here, 3 over 8. So again, the y is labeled as percentage. X is labeled as years. So it goes down 3%, or sorry, it goes up because it's positive. It goes up 3% for every 8 years. And then let's go ahead and do that last one. So this bottom point is about 2013. Let's see, about 25%. So last part is going to be 25 minus 26 over 2013 minus 2011. So we're going to have negative 1, 2013 minus 2011 is 2. So it's 1/2, so it's going to be negative 1%. So going down 1% for every 2 years. So this is kind of understanding this piecewise, kind of showing how the slopes or the rates change for every different piece. All right, let's go ahead and turn to page 87 through 88. This is Lena, how she filled up her bathtub, gave her dog a bath, and then she took the water out. And it says, the graph shows the amount, right? And in the tub, the water is in gallons, and it's a function of time in minutes. Let's go ahead and label our axis. So go ahead and pause and label those, and then go ahead and come back to me. All right, so first thing we have to figure out is which one is the independent and which one's the dependent variable, right? And so then knowing the dependent and the independent, then we can go ahead and label things. So does time depend on the water, or does the water depend on the time? And if you really kind of think about it, the water is going to go ahead and depend on the time. So that means the x-axis is going to be our time, right? We can say time. We also need to be a little bit more specific. it's going to be minutes. And then the y-axis, it's going to be our water, and it's going to be in gallons. All right, let's go ahead and figure out, when did she turn off the water faucet? Go ahead and answer that question, pause and answer that question, and then come back to me. Let's go ahead and look at this graph. So it starts down here, right? This is where there's no water, and then she's going to go ahead and fill it. And then here it ends up stopping, right? So where did that happen? Well, that happened at 6 minutes. So at 6 minutes. All right, number 3, how much water was in the tub to drain completely? So go ahead and pause, answer that question, and then come back to me. So as far as here, this is how much water is actually in the tub. And let's look over what is that? Oh, that's going to be 24. But we have to go ahead and put a label with that. That's going to be 24 gallons. All right, number 4. How long did it take for the tub to drain completely? So draining out, how long did that take? So go ahead and pause, answer that question, and then come back to me. So it starts from here, draining out. Okay, so stays, and then she starts draining out. Well, where does that starts at 18. But then it goes all the way up to 30. So how do we go ahead and figure that out? We're going to go 30 minus 18. Grab a calculator. Let's go ahead and do that. 30 minus 18. What is that? That is going to be 12. Is that 12 gallons? No, that's 12 minutes is how long it went ahead and drained. Okay, and then number 5. At what rate did the faucet fill the tub? Remember, rate is the same, it's another word for slope. Okay, so we'll go ahead and figure out the slope for when the faucet filled up. So let's go ahead and figure out that part. So we're starting here at 0, 0. And then we're going to come all the way up here at 6, 24. That's a 6. And then let's go ahead and figure out that slope, right? So remember, it's a change of y over the change of x. So our y's, we're going to say 24 minus 0, which is 24. And then we're going to say 6 minus 0, which is 6. So 24 divided by 6, well, that's 4. And it's 4 over 1. So let's go ahead and label it. So it's 4 gallons for every 1 minute, as far as it's the rate that it's filling up. Let's go ahead and do the same thing for number 6, but we're doing it as far as how far does it drain. So go ahead and answer that question, pause and answer that question, and then come back to me. So as far as it's going to start here, so this point is 18, 24, and then it comes all the way down here, which is 30, 0. Let's find our rate of change. So let's subtract off our y's, because it's always y over x. So let's go ahead and subtract off our x's, which is 30 minus 18. 24 minus 0 is 24. 30 minus 18 is 12. So let's do 24 divided by 12, which is 2 over 1. 2 or 2 over 1. So it is 2 gallons for every 1 minute. And that's how it goes ahead and drains out of the tub. So this is just a way of looking at this graph, looking at different pieces of this graph and finding out the slopes, finding out different information as far as our x and our y, or our independent variable and our dependent variable. So let's go ahead and let's apply what we kind of just barely did to what's going on here. Turn to page 88, and it says the graph shows the speed of a car as a function of time. Describe what a person watching the car would see. So you're writing a story to go along with this. And so go ahead and pause, write that in on page 88. What is the story that will go ahead and go with this? Pause, and then come back to me. All right, I'm going to go ahead and write down my story. My story might be the same as yours, or it might be different. But I'm going to say, okay, The car begins at rest, meaning it's not going anywhere, and then quickly picks up speed after some time. It reaches its maximum speed. And stays at that speed for a while. Then the car gradually slows down and comes to a stop. So this is my story, kind of goes with it. You can even start it where the car begins at a rest at a light, and the light turns green, and then it quickly picks up speed, drives at a certain speed for a certain amount of time, and then starts coming to another red light, so it slows down, and eventually it stops at the red light. However you did that story would be great for this. So again, we know that this is because it's speed. It's going up the hill, our speed's getting faster, stays there for a while because this is a slope of 0, so it doesn't change, and then eventually it's going to come down or go slower because it's going down the hill. And then again, we're talking about that speed and then over a course of time. So hopefully you understand what kind of story would go along with this graph. So let's kind of think about it. How would we describe a piecewise linear function? Well, that is where we have that graph, and it's kind of a graph that goes with a curved data points. And so we're putting a straight line on a curved graph, and then we're taking that piece of information and we're understanding it. We're understanding what is the rate of change, how does it change, what information do we know, and then we can kind of take it just different pieces of that tiny little graph, and it will tell us specifically what's going on. So instead of just overall general, because sometimes that doesn't give us enough information, we have to take it and put it in little pieces of chunks, and then that will tell us kind of what's going on with it. So go ahead and turn back to page 190. Read the I can statement. I can create graphs of nonlinear functions with pieces of linear functions. Go ahead and write yourself a sentence, how you feel about that. Give yourself a number. So 1, I'm still confused. 2, I kind of got it. 3, I did get it. And then 4, I can teach it to my friend. So give yourself a number and a sentence. And then make sure you go ahead and do the practice problems. You can find those in Canvas. Thanks. Have a good day.